Alright, in this tutorial we're going to go over how to identify monomials. Now monomials are just a specific term, and it could be any of the following. It could be a number. A single number by itself is a monomial. It could be a variable, just the letter X, Y, A, B, any single variable, or the product of a number and a variable. Now remember, the product is another way to say multiply. So if you're taking some type of multiplication of a number and a variable, like 4x, that is also a monomial. So multiplication is allowed to happen. It could be a number and it could be a variable. And it has to have positive exponents. In our last unit, a lot of the terms that we were simplifying, our final solutions or final expressions, had to have positive exponents. If there were any negatives, you needed to use the negative property to move it into either the numerator or the denominator, the opposite side of that fraction. So this is the exact same way. A monomial has to have positive exponents. If it has negative exponents, it's not a monomial. So a couple different examples, in fact, 3 different specific ones. Again, the letter X, just by itself, that is a variable. That is a monomial. 3xy squared. So the only thing that's happening right now is a multiplication between the 3, which is a number, between the x, which is a variable, and then between the y squared, which is a variable that has a positive exponents. Negative 2x squared, y to the third, and z. This entire thing is also a monomial. Now your coefficient, the number in front right here, could contain a negative. That has nothing to do with making it not a monomial. Your x squared right here is being multiplied. Still multiplication product. That's a monomial. Y to the third power, positive exponent, being multiplied. Same thing. These are all different examples of monomials. Now, something that makes it not a monomial is that there cannot be any addition or subtraction between monomials. So if I were to take 2 of these monomials right here, x plus 3xy squared. Now each of these things individually, this x is a monomial, this 3y squared is a monomial, but the entire thing together is not a monomial. We'll get into what that's called in a later section, but if you have any addition or subtraction, that entire thing is not a monomial. Okay, you can have individual monomials within that expression, but the entire thing itself is not. So a lot of what we're going to be doing this section is just answering yes or no. Is this a monomial? Is this not a monomial? So let's look at the first example. Is 83jk to the third power a monomial? So what we've got right now is we've got a number. We're good so far. Then it's being multiplied times the j, product, multiplication, we're good, times k to the third. Let's make sure we have a positive exponent. Yes, we do. So this satisfies our criteria. There's no addition, there's no subtraction. So yes, that is a monomial. Now into the second one, 3 plus 5t squared plus 3u minus 5t. Now what you notice right here is that there are 3 different addition or subtraction symbols. So you have different monomials within this expression. In fact, you have 4 monomials, but the entire thing is what is being asked of you. Is this entire expression a monomial? And no, it is not, because you have addition and you have subtraction. Even if you only had 1, let's say it was just 3 plus 5t squared. Even that entire thing is still not a monomial. We'll get into what that's called later again. Mono just means 1. You have one of those terms, one of those things, that is add or subtract.